Subscribe to my channel and hit the bell icon so you never miss any video from my channel.
Let's have a go at balancing an equation. Sodium hydroxide is a soluble salt, but most other hydroxides are insoluble. They can be made by reacting with sodium hydroxide, like this. A good way to balance an equation is to use a table to keep track of everything. You can list the number of each atom on the left-hand side and the right-hand side of the equation, then compare to see if they are the same. Remember, you can only change the big number in front of compounds, which says how many molecules you have. You can't break up bonds to make it balance. Try filling in this table now. Pause the video whilst you add up the atoms. Are you ready? These are the numbers you should have found. We can see that the metals are balanced, but there are 3 times as many chlorine atoms on the left and 3 times as many oxygen and hydrogen atoms on the right. So let's multiply the compound containing chlorine on the right by 3 and the compound containing hydroxide on the left by 3. Is it balanced? Pause the video whilst you fill in the table again. What do you get? The equation is now balanced. Let's look at some reactions that come up elsewhere in chemistry. Can you balance these? Pause the video again and have a go. Now let's see the answers. Here they are. If you made a mistake, remember to redraw the whole table and count up the atoms every time you change the numbers at the front. Sometimes it takes a bit of trial and error. If there are charges in a formula, these also need to be balanced. Look at this reaction for the oxidation of cobalt, for example. We can start off by balancing the atoms. Here's a table like the one we used before. There are half as many hydrogens and oxygens on the right as the left, so let's double them. If we test this using our table to add up the atoms, it looks balanced. See? But on the left, the total charge is +2, whilst on the right, the total charge is +3 minus 1 times 2, which gives +1 overall. We have gained 1 electron. As we know, matter cannot be made out of nothing, so we can't make an electron appear like this. We also need to balance the charges. The easiest way to do this is to change the number of cobalt ions on each side of the equation. We have to change them by the same amount, so the atoms stay balanced, but because they have different charges, the ratio of charge on the left to the right should change. Now both the atoms and charges balance. Nothing has appeared or disappeared. This is the most important rule about balancing. No atoms or charges can be made or destroyed. You should now feel confident counting up the atoms in a compound and balancing them on 2 sides of an equation. And don't forget to look out for charges and balance these too.